Okay, so this is 4.2.1, day 1. We're going to do numbers 4-58 and 4-59. So we're kind of doing the same thing, except we are now solving inequalities as opposed to equations. So what's an inequality? What's an equation? Well, an equation has an equal sign. An inequality will have an inequality symbol. So a greater than or equal to, less than or equal to, or just a greater than symbol or a less than symbol, okay? And if we look at 458, we're given two equations, and we found where they intersected, right? So we would put them on the graph on Desmos, or we would solve them algebraically, and we would find the point or points where they would cross paths, right? And if we look at letter A, we have this picture right here, and I see that it is intersecting at -3 and also at 2. Okay? So what are the solutions? We would say x equals -3 and x equals 2. We had two solutions to this. Now we're going to take this same picture and we're going to blow it up on the second page. And we're going to make these inequalities instead of equations. Okay, so we're going to look at the picture down here. Okay, and I'm going to highlight what each equation is. Okay, and I know that this equation, or this well, it's going to be an inequality, but this is this one right here, the 2x squared plus 5x minus 3. And the orange one is this one right here. Okay, it's just a little easier if we use colors. Okay, and in between here, unfortunately, the less than or equal to did not show up, so I'm going to put, oops, I don't want to do that big. I'm going to put, kind of white this out, and it should be a less than or equal to symbol. So if you can go ahead and do that on your notes. And I want to know, when is the yellow graph less than or equal to the orange graph? Okay, it makes sense now that I'm saying colors. When is yellow less than orange? When is the yellow graph lower than the orange? Well, we can see all right here, right? All right here. And it starts at -3. That's when it's equal to it. All these points right here. And it ends at +2. So let me give you a little tip. We talked about these symbols before. If you have one of these symbols, we are going to say it's included, the solution's including it, so we're going to make a closed circle. And if it just has a greater than or a less than symbol, it will be an open circle. So we have, if we look here, a less than or equal to symbol. So I am going to put a closed circle at -3 and a closed circle at +2, because that's where they're equal to. And in between all of there is when all of these points fit the solution. All of the yellow graph is below or less than the orange graph. So we're going to color that section in. We're going to shade it in. Okay. Now let's do that again, but let's change the symbol. We have our yellow graph and our orange graph. Where is the yellow graph greater than the orange graph? Where is the yellow graph bigger than the orange graph? And I can see it's actually in two sections. Right here, the yellow is bigger, and right here. So that's two different pieces to the graph, right? So now we're talking about a greater than symbol, which is an open circle, and it starts at -3. And if we notice again, it's shooting left and up, but it's shooting left. So we're going to color this area in. And put an arrow to show that it goes on forever. And then on this part on the right, it starts at 2 and it shoots off to the upper right. So here we're going to put a open circle at 2 and shoot it this way. Now we need to write these not only graphically, but algebraically. I'm going to use that in red. Here, we've got from -3 to 2. So that's algebraically how we're going to represent our solution between -3 and 2, including those ends. When they're shooting outward, like one's going one way, one's going the other way, that's an OR graph. So it's from 3 or -3. And notice that this arrow kind of matches. It kind of tells you what you want to write. Okay. Same thing over here. It starts at 2. So x is greater than 2 and it shoots to the right. Again, this arrow is showing me that I want to display that it's everything greater than 2. So it's over 2, 2.1, all the way 4, 5, 7, 10, 1,000. Okay, and we're going to put the word OR in between. So that is how we're going to write the two algebraic solutions as well as the graphic solution. Okay, let's go on to 459. A little different problem. We've got an absolute value problem. We're going to find what's called the boundary points, the solutions. We're going to pretend that this is an equation. Okay, and we've done these before. So I'm going to take my inequality and I'm just going to forget about it for a while. And I'm going to put an equal sign there. And I'm going to start solving this. So first thing I need to do is add 2. So I get 4 times the absolute value of x plus 1 equals 8. I'm going to divide by 4. And I get x plus 1 equals 2. And now when you have isolated the absolute value, you're going to split it into 2 equations. X plus 1 equals 2. X plus 1 equals -2. And you are going to solve. So x equals 1. Subtract 1 here. X equals -3. These are called the boundary points. Okay. And you're going to see in part B, we're going to put them on a number line. Okay, so here we go on a number line. Now the smallest number goes on the left, the bigger number goes on the right. So -3, +1. Now, we're going to go back to our symbol now. Our symbol was a greater than symbol, which means open circles. So I'm going to put an open circle on each one. Now, if you notice, I've got kind of 3 sections on this number line. I've got section A, section B, and section C, don't I? We are going to test a number into the original equation from each section, and if it comes out to be true, we're going to color in or shade that section. If it comes out to be false, we are not going to color in that section. So I'm going to take my equation, my 4, and then x plus 1 minus 2 greater than 6. I am going to put a number right here from each section. All right, so at first I'm going to put in a number from section A. So if I put in a number from section A, how about we use -4? I'm going to put a -4 in there. Okay, and you can put this into your calculator. I'm pulling up Desmos, but you certainly want to use your graphing calculator to make it a little easier. To pull up an absolute value bar, you're going to hit Math. You're going to move over to the NUM at the top, and then the number 1 option is ABS, and it will pull up absolute value bars. So here I'm going to do 4 and then -4 plus 1 minus 2. And I want to know, oops, not times 2, minus 2. I want to know, is that greater than 6? Well, in section A, I get 10. Yeah, 10 is greater than 6. So we are definitely coloring in section A. Let's try section B. Okay, let me use a different number. In section B, I think it's safe to use 0. That's definitely in the middle of section B. So I'm going to put a 0 here. Okay, so all I'm going to do is go back up here and change this to a 0. And I get a 2. Is 2 greater than 6? Not at all. 2 is not greater than 6. Okay, so now lastly, let's choose something from section C. A 2 or a 3 or a 5. Let's use a 5. Let's just choose any number from section C. We'll put a 5 in there. And I'm going to change my Desmos to a 5. And I get 22. Is 22 greater than 6? Sure is. So sections A and C get colored in. So I'm going to go ahead and do that. Here's section A. Color that in with the arrow. Section C gets colored in. B was not a solution, so we're not going to color that in. And now, if you remember from up here, how we wrote it algebraically, we're going to do the same thing right here. X is less than -3 or x is greater than 1. So both of these are solutions. One's algebraic, one is a graphical explanation. But both of them show the same type of thing. Okay? Part 2 will be up next. Thank you.